Why bother with statistics? Part 3. You can argue anything. In the final video in this series, we will look at some factors that will allow us to get the most out of statistics, so we don't argue anything, or accept anything being argued, other than the most accurate interpretation of information we can find. We will look at the following factors: sample size and inclusion of data, quantitative versus qualitative data, correlation versus causation, mean, median, minimum and maximum. An important aspect in dealing with statistics is the sample size. This is important in how accurate the data collected is. Using an example, we could have a bad sample size of all my friends whom I meet in the pub agree that women rarely drink alcohol. An example of a good sample size at the other end of the spectrum is from the National Survey on Drug Use and Health, which covers alcohol use amongst women of different age groups. The larger sample size is more likely to yield accurate results about the general population of women and how rarely they drink alcohol. In the National Survey on Drug Use and Health, 35,129 women were surveyed in 2019, and the 18 plus group, 51% of women drank alcohol in the last month, 18 to 25, 54.7%, and 26 plus, 50.4% drank alcohol in the last month. Another consideration with a sample size is that you can have increased insights or more unknowns depending on what is included. So in the National Survey on Drug Use and Health, they had breakdowns by gender, ethnicity, and age. See the different categories across the screen. Another important factor is what is excluded from the data. A good example of this is unemployment statistics. In the USA, the current population survey has a random sample size of 60,000 households to calculate unemployment every month. Included in those statistics are those who are employed and those who are not employed but looking for work. This means that anyone not looking for work isn't included in the statistics. This means that if you included those not looking for work and those looking for work, this would increase the percentage of people who would be counted as unemployed. In the UK, there are two methods: the labour force survey, which works the same way as the current population survey, and the claimant count. The claimant count looks at the number of people out of the population who are taking job seekers allowance. This is a government handout which people can get when unemployed if they are seeking out new work. The issue with this is that it excludes other government handouts and people who are unemployed who are not on JSA. So if you know what is included and what is excluded, then you will know when someone is arguing something which is not fully accurate. This is why understanding how statistics are put together can help you to be able to dismiss arguments that are distorting the truth of the matter. Now we'll look at some definitions for qualitative and quantitative data. Qualitative data from Merriam-Webster of relating to or involving quality or kind. The Oxford Learner's Dictionary for qualitative, connected with what something is like or how good it is, rather than with how much of it there is. Quantitative from the Merriam-Webster, of relating to or involving the measurement or quantity of something. Oxford Learner's Dictionary, connected with the amount or number of something rather than with how good it is. Qualitative information can be really good at giving insights into people's reasoning and explaining people's motivations, but psychological factors can have a much bigger role in how people give answers. Some factors could include: there is a motivation to lie if the truth of the information could be seen as embarrassing. This could be more prominent if the answers are not anonymized. Group influence: if many people in a group are seen to have made a particular decision, that could impact the result. The evidence for this can be seen in Ash's Studies of Independence and Conformity, a minority of one against a unanimous majority. 75% of people in that study were shown to change their answers to a wrong answer if there is a group consensus on the wrong answer. The advantage of quantitative information is you can clearly see numbers of something, such as the value of Apple shares. Whilst people's confidence on Apple could contribute to the share price, the measurement is focusing on what that ultimate share value is, rather than the factors that go into that valuation. This can provide a powerful understanding of Apple's business performance on the Nasdaq Stock Exchange over time. Correlation is two variables that are linearly related, and they can be arranged from highly inaccurate to very accurate. A bad correlation example could be the sun rises when you get up out of bed in the morning. Therefore, the sun only rises when you get out of bed. A decent correlation could be seen in the research by René D. Goodwin, looking at the association between physical activity and mental disorders among adults in the United States, which showed that there is a negative correlation between physical exercise and depressive and anxiety disorders across the US population. The sample size for this is 8,098 people across ages 15 to 54. Causation is more useful because that information shows something that is directly or indirectly caused by something. This type of data will more likely show the source of something. If we refer back to Ash's study, it is clear the consensus was causally related to people choosing wrong answers instead of the correct ones. The mean is the sum of the data divided by the number of data points you have got. Often the mean can be used in arguments such as with the gender pay gap, which argues men on average get paid more than women. The mean can only give a very overall view on something. So with the gender pay gap, questions of hours worked, personality impacts, IQ, job interests, and many more issues are factors that can come into play, which are not included when just looking at the mean. To identify an issue of inequality just from differences in the mean across the population is unwise because it doesn't give enough information on the causes. Medians use the middle number, which is far more representative of where the middle in data actually is, and is also used in analysing the gender pay gap. Let's say you have 5 people earning $25,000, $30,000, $35,000, another with $35,000, and another with $170,000. The problem taking the mean here is the answer is $59,000, which is not really representative of where the salaries are in the middle of the data, because you have a largely different outlier at the top. This is where the median is useful. When you order all the salaries from smallest to largest, the third one is 35,000, which is the middle of the data. This can also be used as a tool for the gender pay gap, whilst it deals with the issue of outliers that the mean doesn't deal with well. It still doesn't take into account all the other factors already mentioned. Minimum and maximum are excellent for establishing ranges of data, but will not give you the full conclusion of what is being demonstrated. Using the IQ example that we previously looked at, you can see the ranges are generally 55 to 145. So if someone comes along and says they have 700 or 25 IQ, you know that is not going to be correct. After considering all of these different factors, we can now use this to put together opinions formed on a factual basis. An example of this could be, I think it is a bad idea to have a survey completed where people are allowed to discuss their answers before answering the survey. This is because in Ash's study of independence and conformity, a minority of one against a unanimous majority, it was demonstrated that most people will change their answers to conform to a group. This series should help you determine if you should bother with arguments based on statistics or not. These ideas can be used to help you determine the value of research for yourself. Some questions for discussion. How helpful do you find considering how data is put together? Have you had experiences where you have found statistics and studies that were highly problematic? Let me know in the comments. Like, subscribe, and hit the notification bell. Join me again as we research our world.